Hello students, so today the topic we are going to discuss is quantum numbers of an electron. So we will see what are quantum numbers and why they are important and how can we determine the quantum numbers for an electron present in an atom. So let's start. So what is quantum number? So quantum number or quantum numbers for an electron. So these are set of four numbers which represent the position and energy of an electron present in an atom. So as you know, in an atom there can be multiple electrons. So for defining the position and energy of each electron separately, these quantum numbers are used. So there are four quantum numbers which will be needed to completely specify the position and energy of an electron. So what are these four quantum numbers? So I will write their name. So first quantum number, that is called principal quantum number. Second quantum number, that is called azimuthal quantum number. Third one is called magnetic quantum number, and last one, that is called spin quantum number. And there are symbols with which we represent these quantum numbers. Principal quantum number is represented by letter small n. Azimuthal quantum number is represented by letter small l. Magnetic quantum number is represented by symbol small m or sometimes by small m in suffix l. And spin quantum number is represented by symbol small s. Okay, so these are the four quantum numbers, and all these four quantum numbers need to be specified specifically for an electron. Only then we can completely describe the position and energy of that electron present in an atom. So let us see what these quantum numbers represent. So these quantum numbers, first quantum number, principal quantum number, this represents the shell or orbit of the electron. Shell or orbit, so it tells you in which shell or in which orbit the electron, it is in the first orbit, second orbit, third orbit, or any other orbit. So principal quantum number tells you about the shell or orbit of the electron. What does this azimuthal quantum number tell you? Azimuthal quantum number tell you about the subshell of the electron. So if you remember, shell or orbit of the electron, they are represented by letters, English alphabets, capital K, L, M, N, and so on. And subshell of an atom, they are represented by symbols S, P, D, F, and so on. So we don't need subcells beyond F. So SPDF, these four subcells are sufficient to accommodate all the electrons present in all the atoms found in nature. Magnetic quantum number, so they represent the orbital of the electron. So as you know, in each subcell there are multiple orbitals possible, right? In S subcell there is only one orbital, in P subcell there are 3 orbitals, in D there are 5, and in F subcell there are 7 orbitals. So magnetic quantum number specifies in which orbital exactly the electron is present. And what does spin quantum number tells you? Spin quantum number tells you about the spin of the electron, because in one orbital there can be 2 electrons maximum, and the spin of those 2 electrons is opposite to each other. If one electron is revolving clockwise, then other will be revolving anti-clockwise. So it represents the spin. So spin of electron is represented by the last spin quantum number. So these four quantum numbers we need, and let us see how can we find these set of quantum numbers. So n, what values n can occupy? So n is always shell of the cell or orbit of the electron. So for first cell, if the electron is present in the first cell, the n value will be 1 for that electron. If electron is present in the second orbit, the principal quantum number for that electron will be 2. Similarly, for third orbit it will be 3, for fourth orbit it will be 4, and so on. Now if you know the n value, like principal quantum number, then what will be the azimuthal quantum number, L? So what is L? L value, suppose you have a particular value of n, then L value starts from 0 to n minus 1. What does this mean? 0 to n minus 1, and what it can be. So if L value is 0, what does this represent? This represents that the electron is present in S subcell. If the electron is present in P subcell, then you will write L equal to 1. So L equal to 1 represents P subcell. Similarly, if L is 2, you will write the electron is present in D subcell, and at last if L value is 3, then electron is present in F subcell. So you will particularly find in which subcell the electron is present. If electron is present in S, you will write L equal to 0. If electron is present in P subcell, you will write L equal to 1. If electron is present in D subcell, you will write L equal to 2. If electron is present in F subcell, then you will write L equal to 3. Okay, so we found two quantum numbers. Now third quantum number, m equal to. So what is m? M value is from minus L to plus L, including 0. So how will you find this? Suppose you found a particular value of L. Suppose you found L is equal to 2, for example, right? So you know that electron is present somewhere in the D subcell. Then what can be m value? It will be from minus 2 to plus 2. So it will be from minus 2, minus 1, 0, plus 1 and plus 2. Why these 5 values? Because in D subcell, you know, there are 5 orbitals, right? So there can be 1, 2, 3, 4 and 5. So electron can be present in any one of these. So if electron is present in this first orbital, you will write m is equal to minus 2. If electron is present in the second orbital, you will write m equal to minus 1. If electron is present in this third orbital, you will write m equal to 0. If in this orbital, you will write m equal to plus 1. In this orbital, you will write m equal to plus 2. So for an electron present in an orbital, so it tells you the third quantum number, magnetic quantum number, tells you that in which particular orbital of the subcell the electron is present. So if you exactly know electron is present in a S subcell or P subcell or D subcell or F subcell, then specifically you can go inside that subcell and you can find in which orbital that electron is lying, and accordingly that will give you the value of the magnetic quantum number, right? And last one, the spin quantum number S. So spin quantum number S has only two possible values, either plus half or minus half. So how is this determined? If an electron is moving clockwise, so in an orbital there can be two electrons. So like this, if electron is moving clockwise, the spin quantum number for this will be plus half, and if an electron is moving counterclockwise or anti-clockwise, the spin quantum number for this will be minus half. If an orbital is containing only one electron, then one electron can be clockwise or it can be anti-clockwise also. For one single electron present in an orbital, S can be plus or minus both, right? It can be, but not both. It can be any one of these values. So I hope you understood how will we find the quantum number for an electron. Let's take an example and try to understand this topic more. So we will find the quantum number, let us say the last electron of nitrogen atom. So suppose the question is you have to find the quantum numbers for the last electron of nitrogen atom. So nitrogen atom has atomic number 7, so it will have 7 electrons. So its configuration, if you write in orbits, it will be 2, 5, and in the subcells you will write is has 1s2, 2s2, 2p3, right? 2, 2, 4 plus 3, 7. And what is said, how if last electron where it will come? So last electron will come into this 2p3 subcell. So how will you draw this pictorially? So 2p. So p subcell has 3 orbitals. So this is px, py, pz. So you will choose this one. Last electron is present somewhere here. So it is second. So this number here, this will give you the principal quantum number. So n for this last electron of the nitrogen atom, n will be 2. And what will be L? Because the electron is present in p subcell, so for p subcell L is equal to 1. So if you remember, I told you that L is equal to 0 for S subcell, 1 for p subcell, 2 for D subcell, and 3 for F subcell. So as electron is present here in the p subcell, so you will write L is equal to 1. Okay, so now let's write the electronic configuration. So 2p3, so there are 3 electrons in the p subcell. So first electron, second electron, third electron. So this is Hund's rule of maximum multiplicity, that electrons don't pair in a subcell until each orbital of that subcell contains 1 electron. So first you try to maximize the number of unpaired electrons. So this will be the 2p3 configuration. So this is first, second and third. So this is the last third electron present in the nitrogen atom. So we found the n value, we found the L value. What will be m? So if you remember, m value is from minus L to plus L. So it is L is 1 here, so it will be minus 1, 0, plus 1. Okay? From minus L to plus L including 0. So what is m value for this last electron? We have circled here. So m is here, as you can see, this is plus 1. And as the electron is moving, it is single electron present in this orbital, so you can write S is equal to either plus half or minus half, it doesn't matter. So let's write plus half, or minus half will also be a correct answer. So these 4 numbers are the quantum numbers for the last electron of nitrogen atom. Let's consider one more example. Let us say quantum numbers for last electron of chromium atom. So if you remember chromium atom, so chromium's electronic configuration, because its atomic number is 24, so its electronic configuration is 2, 8, 13, 1, right? I have written it correctly. So 8 plus 2, 10, plus 10, 20, 23, plus 1, 24. So 2, 8, 13, 1. So you know that it is little different from conventional electronic configuration, because to maximize the number of 5 unpaired electrons in d orbital, 1 electron from the outermost cell comes into the d subcell. So last electron comes here. So if you write it in orbitals or subcells, this configuration will be 1s2, 2s2, 2p6, 3s2, 3p6, and 3d5, and last one is 4s1. So last electron, because you know that after 3s2, 3p6, 4s1 gets filled, and after that 3d5 is get filled. So last electron will be coming here in 3d5. Let's draw it pictorially. So d subcell has 5 orbitals, 1, 2, 3, 4, 5. So this 3d5, how can we distribute 5 electrons in this d subcell? So 1, 2, 3, 4, 5. So this is our last electron here. So let's get this. This is your subcell where the last electron is present. So what is this number here? This number will give you the principal quantum number. So for the last electron, you will write n is 3 because it is present in the third cell. Now it is present in d subcell, right? So this d will tell you that L is equal to 2, because you know I told you here L is equal to 0 if it is S, 1 for P, 2 for D, 3 for F. It is D, so you will write L is equal to 2. And what will be M? M value is from minus L to plus L. So minus L to plus L, because L is 2 here, so it will be minus 2, minus 1, 0, plus 1 and plus 2, right? So what do you see here for this last electron? We have written here For this, what is m value? M value is this one, it is plus 2. And what you will write as spin quantum number? It is single electron present in an orbital, so it can be either plus half or minus half. Any answer will be correct, so let's write plus half. You can write minus half also, that will also be correct. So these are the set of 4 quantum numbers for the last electron present in chromium atom. So I hope you understood this topic quantum numbers and you enjoyed understanding this topic. So we will meet again with some new interesting topic. Till then, take care. Bye bye. Thank you very much. And don't forget to subscribe my channel and post your doubts, comments or questions in the comment section. I will try my best to answer those comments. So thank you very much.